everyone. Let me give you an update on Xen FuSa and the activity of the special interest group on safety. So what is safety? Safety is everything that, in terms of software safety is everything that related to software when software can harm people's lives. In all situations where human lives can be at risk, like in a car or in a train, in an airplane, but not just transportation, also in industry or medical devices need software too, right? So there are a number of devices in the industry that can have a direct effect on people's lives. In these cases, safety certifications are often required to certify that the software is at the utmost level of quality, is not going to crash, damaging the person, the individual using it, and in general is really, as you know, in terms of process, it has been developed with the best process possible to lead to a great quality in terms of the code base. One of the most used certification, and also the one that we're targeting on, is ISO 26262, and involves both coding guidelines as well as documentation and process requirements. Why Xen matters for safety? So Xen has always been used or has been used for a number of years now in mixed criticality deployments. A mixed criticality deployment is a deployment where something critical is running alongside something non-critical. And Xen typically is responsible to maintain isolation and security between these two different environments. This has been used for security now, again, many times, like QBOS, OpenXT. If you think about it, they're mixed criticality environments too. Like they separate your critical workspace from your non-critical workspace, or they give you a secure desktop and they isolate it from the non-secure desktop. And this is the same as what we do at Xilinx now, AMD in embedded. So we provide our customer with a critical environment with typically a real-time OS to control a motor function, for instance, in an industrial controller, to separate it out from what is the UI or larger Linux software to send data to the cloud, but that is non-critical typically. So this is just what we do and we have been doing so far. It's just similar, but the critical part has real-time requirements. So we also have to isolate the critical in terms of real-time and real-time deadlines to make sure that the non-critical environment cannot make the critical environment lose any deadlines. So safety critical systems are just another flavor of mixed criticality systems. They're nothing else but mixed criticality system where the critical software, critical component also needs to be safety certified. Why Xen is a good fit for safety? Well, safety certification requires that the code is written with very, very tight controls over quality, so very strict reviews. And also it helps if the code base is very small, exactly because, you know, fewer lines of code, fewer bugs, and definitely you want as fewer or zero bugs if possible in safety deployments. So having a small code base and a microkernel architecture where you can run large portions of the code base non-privileged in DOM-use, it helps a lot. It helps that we don't even need a DOM0 now with DOM0-less deployments. That another huge part of the code base that doesn't need to be certified anymore. We do support real-time and cache coloring, and I would say world famous strict review process and also security process, both of them come to an advantage in terms of safety because they help prove that our processes and their quality are as good as they can get. Now, getting more into FuSa and what we do specifically with Xen FuSa and the goal of the SIG, we know that Xen can be safety certified. Now, that is not in question anymore. Safety certification assessors, these are the companies that look at your processes at code base and declare that is safe, and therefore they give you a certification for it, such as Exida, maybe they're the most famous in the industry, but there are others, there is TUV. They have said multiple times over the years, and also recently, that Xen can be safety certified. So that's not really in question. The question is, at what cost? I mean, what do we really need to do? What changes we need to make? What documentation we need to produce to achieve the certification? Now, we certainly have gaps, and the goal of the FuSa group is to make Xen easier to safety certify. So, like I said, we already know that a user, a customer downstream could take Xen and then do the safety certification. But he will have to do a decent amount of work to get there. And if two users need to do that, both of them need to do it. Both of them need to do pretty much the same amount of work separately with duplication of efforts. The goal of the SIG is to make upstream as much as possible closer and aligned with safety certifications, so that the work that the user needs to do to safety certify Xen is as small as possible, decreasing over time, and ideally small, as close to zero as possible. But we're still talking about safety certifiable in the sense that we are okay with a little bit of work to be done, right? We're not trying to make Xen safety certified by Xen project, right? The safety certification is not something that, the certificate itself we are looking after. We're just trying to make Xen easier for others to safety certify. So one or two gaps might be okay. Doesn't have to be 100%. And the other thing is, we really want to focus on what we do best, robustness of the code. So like I said, safety certifications include a lot of things, including a lot of documentation required and testing, and also robustness of the code. So, the upstream community, what it does best is the code itself. So it's only natural that the FuSa SIG focus on the code first. But I want to, as the last point on this slide is quite important, which is clarity. So it might be okay to have gaps, but it's really, really important to be very clear about what we support and what we don't support, what is our process and what is not our process. This is actually maybe, among everything, the most important activity of the SIG. If we just clarify what is that we already support, what is that we already do, what are the MISRA-C rules that we already do, what are the review processes that we already follow, or the security processes that we already follow. Thankfully, a lot of it is already documented. But many of these things is just a matter of clarity and saying clearly what we do, so that a user could compare it with what the certification require, and relatively easily, estimate and then do the work to fill the gap. Okay, going back to code first, and what is that we do, and I'm trying to focus on the SIG, is we understand that there is a certain process, traceability requirements, documentation, but at the end of the day, everything the safety certifications are for is really for code quality and robustness. And here in the SIG, we are part of the Xen community. The Xen community, all it does is really to produce good quality code and release it. So we're very well aligned on that, and that's also why our primary focus is to make the Xen code base closer and easier and to safety certify. So the first thing that we try to focus on is MISRA. MISRA is the de facto standard for a set of guidelines on writing safe and good quality code. So what we've done so far is we went through the list of MISRA-C rules, and we tailored a subset that makes sense for Xen. Among these rules, we adopted the first 15 out of 100 by having meeting with the relevant maintainers, and then deciding which what to do with each of these individual rules. And what to do I mean adopt them as part of the Xen coding style, so that any new contributors could come in and fix issues, or decide to not adopt them at all. In this case, so it means we cannot use tooling to automatically detect the deviation as I will mention in a second. Or we can even decide to follow this rule, but accept certain deviations. A deviation is somewhere we decide on purpose not to follow the rule because it's safe anyway, or maybe potentially even safer than following the rule. And in those cases, we explain why. All of these options are possible. And again, we started with the first 15 out of 100, and typically so far we have mostly, I guess, the majority of these rules we have decided to adopt them with potentially with deviations where necessary. What is the benefit of adopting these rules? Well, there are a number of the benefits, but maybe the main one is that static code checkers such as Eclair and CPP check can be used to scan patches and also the code base for violations. Now, this is particularly useful for new patches. You can imagine a new contributor, somebody has never written code for Xen, to submit a patch, and before anybody does even any review, automatically CPP check and Eclair can point out all of the violations against the rules that we have established as part of our coding style. That would ease the workload for the maintainers. A lot of things will be done automatically, not without us having to do anything, and the contributor will get a lot of feedback. And usually contributors really like to work with machines rather than people, so it also lessens the stress of making contribution to Xen, because they know they can first get a very, very good quality review automatically by machines rather than the maintainers. Overall, they also improve code quality, of course. It gets a standardized set of guidelines across the code base, which are known to make the code more secure and safe, reducing the number of defects overall. Roberto Bagnara has been helping us. He's part of Bagsang and is also the same company that provides Eclair. And there is an Eclair scanning with results public for Xen. I should mention before moving on that MISRA-C is going to also have as an effect improve compilers compatibility, because that's one of the focus of MISRA-C, and make sure we don't violate C99, the C99 standard, if not on purpose and explicitly, and not use any language extensions, again, if not on purpose and explicitly listing what extension we use. These are the two tools that we're making use so far. So Eclair is more accurate and a high accuracy, more coverage of the rules, and there are public results that you can access to see the latest scan on Xen. There is also CPP checks. It's not as good as Eclair in any way, but it's open source and anybody can run it on their own machine, on their own computer freely to check, a patch or a contribution or whatever branch they have of Xen at the moment. Okay, so moving on from MISRA, so we discussed how the FuSa SIG focuses on code first, because this is what we do best. And also our MISRA-C was one of the first activities for improving the code, and that is all true. But we want to highlight quickly that some of the other development items that we have done recently that seemingly unrelated to safety, they're actually part of the same larger effort. And the first one is cache coloring. Now, cache coloring is a technology to partition the L2 cache in software to ensure latency isolation between VMs. The way it works is it reverse engineers the relationship between physical addresses in memory and cache lines. Therefore, then using this knowledge to allocate smartly pages in memory to VMs so that each VM gets a completely different set of cache lines. Therefore, there is no interference anymore possible because there are no shared cache line between VMs. Now, why is this useful? Because for safety, it's very important to be able to isolate your safety-certified VMs from the non-safety-certified VMs. So that is certainly important in general, but this is also something that matters very much to safety. Basically, that's a brief scheme of how it will work. Before, there could be interference on L2 cache accesses, causing evasion to your safety critical access from other VMs. And afterwards, L2 cache line get separated in software. Therefore, there is no more eviction or interference.
One other part of Xen that we modified lately to enable more safety use case is make Xen more static. Why do we do that? In safety use cases, we want the system to restart in a deterministic way, which means over several restarts of the system, we want to have exactly the same behavior, the same boot time, and the same scheduling of the system. So for that, we introduced several features in the 4.17 release of Xen to make the configuration of Xen more static. This is first DOM0less, which was already there, which allows you to predefine your guest in your system configuration. The second part we introduce is static memory. The goal there is to get rid of the allocator deciding where your physical memory is and define it statically. This is for three items. First, for the RAM of the guest. Now we can define in the device tree where in the physical address space the RAM will be allocated for a guest. Then this is for the Xen heap. We have added features so that you can define what is the size of the Xen heap and where it is in the physical RAM. So you define the address and the size. And finally, that's the guest heap. You define where it is and what size, which means you have a full control of the allocator of Xen and you define where the memory is physically. Then the second part is communication system. So usually a system based on Xen has a DOM0, then you create a guest, and then you create communication channels between DOM0 and the guest or between guests. In a pure DOM0less system without a DOM0, we need to have a communication system. For that, we added two features inside Xen. The first one is static event channel, which allows you to define event channel between guests in your device tree. And the second one is static shared memory. Same thing as the RAM or the static memory. You define a physical area that is accessible by two guests. Using those two communication systems, you can build yourself a simpler communication system. Finally, you want to have a control of the scheduling. So for that, we have CPU pools in a standard DOM0 system. We added the support in Xen so that CPU pools and allocation of the CPU pools can now be defined directly in the device tree, so that you can define statically which cores and which scheduler will be used by a guest. Next slide. The second feature we are working on is MPU support. So first, what is an MPU? An MPU is a memory protection unit. The main difference with an MMU is that there is no address translation. So there is only one-to-one mapping of the memory. The advantage of that is that we can get rid of the page table. And the page table are the main problem in real time, because to go through the page table, you need to access memory, which means the process of accessing a memory address cannot be real time, because either the translation was already done before, so the access is instant, or you need to go through the page table and then you depend on the memory access time. So ARM has introduced in the Cortex-R family, and specifically in the R82, both MPU and MMU support. At EL2 level, so that's the level where Xen is present, there is only an MPU, which means that Xen itself and the guest creation depends on the MPU. So you just define what memory is accessible by a guest, but you cannot translate. At the EL1 level, where guests are running, guests can use either an MPU or an MMU, but not both. This allows to create real-time guests, which are using MPU at EL1, with Xen using MPU at EL2. And on the side, have non-real-time guests like Linux using an MMU at EL1. You can have both types of guests living together on the same system. Currently, this is available as a proof of concept, and we will start the upstreaming shortly after 4.17. Next slide. So, what is next in Xen FuSa? First, we will work on the fine-granular configuration. So why do we want to do that? We want to make the Xen code more modular, because in a safety project, you want to certify only the code that you use. So you want to carve out all the dead code. Making them more fine-granular configurable allows you to select exactly the features that you want and include them, only them, in the final binary. This will allow a more fine tuning of your Xen and allow you to carve out the code that you don't want to certify. So for example, allowing a system without DOM0 less or without DOM0, or removing some DOM0 functionalities because you want to have a DOM0 but only able to control guests but not create them. Remove the 32-bit guest support, etc. So one of the advantages of this work is that it will also help to organize a little bit the code in a better way, because we will have to organize the code in a per functionality way, which could allow to make the general code base of Xen cleaner. Next. The next item we will work on is documentation. So our goal is to try to document all Xen external interfaces. So what external interfaces do we have? First one are the interfaces from the guest point of view. So that's, for example, the hypercalls. You have also the exceptions, which are all the possible mistakes done by guest, and the IO emulations. All those three are, in fact, interfaces from Xen because they provide a functionality to the guest that we have to document properly. Then we have the interfaces coming from the hardware. Xen actually is having an interface with the hardware. It has to handle properly some exceptions which are not triggered by guest. So for example, hardware exceptions which are coming from an hardware error. And it also has to implement correctly the support for interrupts. These are interfaces because those are external from Xen. And finally, there is everything which is coming from the bootloader. That's, for example, the Xen command line or the general configuration which is stored in the device tree. All those have to be documented as external interfaces because that's things where Xen is interfacing to the external world. Next slide. Finally, we want to work on testing. So the goal is definitely to improve the current testing status of Xen. That's both at high level and low level tests. We want to test some specific features like DOM0 less, static configuration. And we want to also be able to have more tests for the external interfaces. That's hypercalls, but also the device tree binding, making sure that they are not broken or that we support all the functionalities that we say we do support, and all the emulated devices. So there are several items we will be working on. First one is a GitLab CI work. This work already started. We want to have more tests and make it easier to use those tests and also for people to add more tests. For example, in a perfect way, every new functionality in Xen should have a corresponding test in GitLab CI. That's the goal we have in the long term. To help with that, we have been working on something named XTP. The goal is to create a framework to implement tests, both at high and low level. We created a first proof of concept, which is available in GitLab. This framework allows to create guest-based tests using either Linux, Zephyr, or XTF for those tests. This is at proposal stage. We plan to have more discussion on this in the future and add more tests. Finally, we want to have more DOM0 less tests. So this work already started and you might have seen some pushes related to that. This is a separate item because definitely XTP is not able to handle DOM0 less tests because it's guest-based test. Next slide. So do you have any questions? And thank you for your attention.
Thank you.